Please let's have a big round of applause for Venkat Subramaniam.
All right. Thank you, thank you. It's a great pleasure to be here to talk about something that I'm sure we all share in common, passion to develop software. So thanks for your time. Just as a quick show of hands, how many of you program for a living or program? That's great, I'm in the right place, just want to make sure. Awesome, awesome, excellent. And how many of you write really bad code? That's good, that's good. So I'll tell you something about myself. Oh, he especially, okay. Well, I'll tell you something about myself. I'll be honest about this. I write terrible code. If you look at my code and say, is that what you do? This is what you write? I write absolutely terrible code. But I'll tell you what I'm really good at. I'm extremely good at finding fault with other people's code. And so what I realized over time is rather than pretending that I can write good code, I write crappy code, give it to my colleagues so they can review it. While they're reviewing it, I review their code. So at the end of the day, we both have better quality code. Well, along the way, I gained that there are certain things we can do, certain principles we can use that can make our lives a lot easier to write better quality software. But I want to emphasize, these are not principles we just sit there in a drawing board and just design. I don't think that really works. But where this really works well is as an incremental development, as we start developing code, as we start doing test-driven development, we can constantly start using some of these principles to better quality software. Now, these principles have been around for a long time, but unfortunately, though, not everybody tends to use them so often, so going through them can help us to get better quality software. Now, one of the things I want to emphasize here is I don't take questions in the very end. The best time to ask questions is when you have it. So don't wait till the end. Any time is a great time for questions, comments, just about anything. But of course, because we're in a large room, if you raise your hand, I will not know it, but make a noise, call out something. I'm sure there's people who can get you a microphone around here, and I would love to have your questions or comments during the talk. Don't let me go on, speak for a long time without asking a question. I'm really capable of giving talks and sleeping at the same time. Don't let me sleep here during the middle of my own talk. So do ask questions, make comments along the way. Don't hesitate. So I want to talk about design principles. I did mention where those principles can be used. And I mentioned that these are really tactical design principles. We can use them as we develop software along the way during test-driven development. But why should we really use these design principles? And the reason is it's really hard for us to know what a better quality software is. We all look at code and say, well, this really looks great. And in fact, I had one guy I was working with who had a really nice definition of good quality software. He said this software is great because I wrote it. Well, there's got to be better ways to decide whether a quality is good or not. So these can help us to really measure the quality of what we do. And I talked about when to use them. But let's get to some principles. One of the first principles I want to talk about is one of my favorite principles. It's called the DRY principle. Now, what does the word DRY really mean? I've really written acronyms here, obviously. We're going to expand those acronyms along the way. So the DRY principle stands for don't repeat yourself. That's the very first principle. People on the way back of the room, give me a thumbs up if the font size is big enough for you. All right, awesome. So we're going to talk about the don't repeat yourself. What does this principle really say? It says that, simply put, every knowledge, so it starts with the knowledge. What is a knowledge? It is rules, it is things we express, logic that we express in code, whatever that we do, every knowledge in a system, so in a system should have a single and authoritative, unambiguous, you can see that keeps going, a representation in the system. So the idea really is, we don't want to be duplicating logic throughout the code in various different places. And this is about DRY principle. Now, oftentimes we immediately talk about duplication, but I want to emphasize the DRY principle is not just about duplication of code, it is also about duplication of effort. Now, let's think about this for a minute. Anybody here who has seen duplicated code? Yeah, some of us have written it, haven't we? Absolutely. Now, I was talking to a group of developers, and one guy told me that every 2 months, they fix the same bugs over and over. I said, oh boy, does somebody actually come back and put the bugs after you fix it? He said, no, we keep discovering the same copy of code in multiple places. I said, well, how does it feel? He said, that sucks. And then after a few minutes, I asked him, so when you do find the copy of code, you refactor it and remove the duplication, right? And there was a pause. He thought for a minute and said, that's a great idea, right? So how do you fix your code if it's duplicated everywhere, right? So we want to definitely remove duplication of code. Duplication is evil. We know that really well. But it's not duplication of code. But let's talk about this for a minute. Why do people duplicate code? Can somebody tell me that? They're lazy. Well, partly so. Anything else? They're afraid. That's absolutely correct. Tell me who's not afraid here. Raise your hand if you're not afraid. A few people. We'll fix that real quickly. Okay, so we all are afraid, right? Absolutely. Why are we afraid? Nobody wants to say, oh, I refactored this code, and then 2 days later, how come all this doesn't work anymore? So nobody wants to take the blame that they refactored the code and something is broken. Hey, it's a path of least resistance. Go ahead and copy and paste the code, and we don't have to worry about breaking anything, right? But had we had really good automated unit testing and regression testing, then of course we can, not duplicate the code, refactor the code, and get a feedback really quickly. So oftentimes lack of feedback causes fear as well. But it's not just the fact that we are worried about duplicating code, it's duplicating effort. What does that really mean, duplicating effort? What that means is you don't want to make a change to a certain part of the system and make yet another change elsewhere and yet another change elsewhere. And just to illustrate this point, I'm going to show you one example. But what I mean by that is, sometimes we say, oh, it's not duplication because I'm not copying and pasting code. Here I had to change Java code. Here I had to change XML file. And here I had to change JavaScript. And here I had to change HTML. Notice all of their different changes, right? No, that's a violation of the drive principle. Why? Because all those changes I just suggested, if they all start because of the same single reason, then it's a violation of the drive principle. Just to understand this, let's take a little example here and play with it. This could be done in several different systems, but I want to show you one example. I'm a huge fan of a little framework called Grails, and I'm going to show you how to really look at drive principle just as one example here. If you notice over here, I've got a team, and the team has a name, as you can see here, and I want to be able to create an object of this team and play with it. So I'm going to go here to a team, create a new team, as you can see in this example, and when I'm about to create this new team, I'm going to say, blah over here. That's a great name, isn't it? So I'm creating a team called blah, and I'm going to go back to a team and say, again, blah one more time, and click on create, and you can see that I was able to create 2 teams with the name blah. Well, I don't want that to happen. So what can I do? Not only can I do this here, I could also edit a team. Notice that in this case, the team already has a name called blah, so that's another window, as you can see. Anyway, let's discard all that for a minute, throw the data out. It's an in-memory database. I don't have to worry about it. So in this case, I'm going to go to one single place. I'm going to say unique is going to be true. That's all I did. I don't have anything under my sleeves. That's all I did. I just made this one change, and I said constraint, and I said that unique is true for the name. That's just one single change we made. But while we are here, let me also say here is, let's call it as contact address. And in this case, I just have a contact address, and I'm going to come back and look at what that means in just a second. Now let's get back to this code for a second and play with it. I threw away the data in the database, so I'm going to say blah is the name, and contact is going to be blah as well. And I click on create. Now I go back to create one more time. I say blah again, and let's just say blah one more time and click on create. And notice in this case, well, it bombed on me. Why? Because I had not restarted the server, so let's go ahead and fix that really quickly. I like systems that get very angry at you, right? Screams loud. That's a good thing than failing quietly. So let's go back and try this one more time. But notice what I just did in this case. I said unique is going to be true. But remember, I could be creating a new team. I could be modifying the name of an existing team. So there is at least 2 places where we got to make a change. But I only made change in one single place. And so let's take a look at what's going to happen in this particular case. So if I go back to this application one more time, and I ask him to create a new team. This time, I'm going to say blah one more time and ask it to go ahead and create it. That created a team. Let's go now and create another team. This time again, I say blah one more time, as you can see in this case. But when I click on create this time, notice it gives me an error on the window that says, hey, that name has to be unique. You cannot do that. Well, okay, let me change it. I'll say blah one here and create another name. But if I go back to this code and go to blah one this time, click on edit, now we are in the edit page and not the new page. But I'm going to go back and create the name as it was before, and we get exactly the same error. So you can see the dryness in this code. We made a change in one place, but that's got impact in two places. Now we could easily say, whenever you look at some concept, you may convince yourselves, yeah, but that was easy because all that had to be back-end checking. What if this had to be a front-end checking? Well, to understand that, let's go back to this code for a second. And once again, I'm going to go back and change the constraint that we have here. But this time, I'm going to say, contact address is email is true. And notice in this case, I mentioned that this is going to be an email, but it's of type email. That's all I did. This is, again, a code on the back end that I've modified to say that this is an email address. Now I go back to new, create blah over here like we did. And notice already you see the difference, don't you? It is red in color. This is UI, and clearly we know that for making change in the UI, you would have to either work with JavaScript or HTML, what have you, but you can see the intelligence in this code. So it took the constraint that we wrote and did two things for us automatically. It generated a back-end verification so that we never send an email that's not valid, but it also generated code for the front end to say, I'm going to stop you from doing this on the front end. We did not duplicate our effort to write this code in both places, and that's what I meant by dry is not duplication of code alone, but it's a duplication of effort as well. Otherwise, it's easy for us to convince, oh, you had to change Java code here and JavaScript over here. That's not really duplication, but the fact is it is duplication because we're doing the same thing and for the same reason, even though the code may be really different on both sides. And in this case, they used HTML5 to push the validation to the client side, and you can see the dryness in here. I'm making sense so far? So the idea is not to duplicate effort and as much as possible. This is not easy. I'm not going to come and tell you that, oh, this is easy to do, but we haven't even given it a chance so far. But if we start thinking about it, we can possibly find a way to do it. And one of the things I want to emphasize is this, and this is something I learned from somebody, and I think this is something to keep in mind quite a bit, because oftentimes we forget it. Because people often tell us, oh, you cannot do this. And if we know that this is something we can actually do, we can put in the effort to do it better. If we don't even know that we can do this, A, and B, if we don't put in enough effort to do it, then I think we failed already. So one of the things I want to emphasize is this, and this is something I remind myself quite often, and that is don't confuse your inability with impossibility. And this is something to think about. I don't even know what impossibility is, as you can see here. I can spell it. Okay, so don't confuse your inability with impossibility, meaning I don't know how to do this. Well, you don't know how to do this, but you and I sit down and start talking about this, and I say something, you say something, I say something, and you immediately say, well, wait a minute, why can't we do this? And now we have a way to solve a problem we thought we can't solve before. So it's well worth spending a little bit of time and effort trying to address some of these principles. That basically is the DRY principle. And what does DRY stand for? I'm sorry, I didn't hear it. Can you say it again? Okay, you get it. Absolutely, don't repeat yourself. Okay, so always they fall for it. What can I say? All right. The next principle I want to talk about is one of my favorite principles. It's called the YAGNI principle. But I'm going to change it just a little bit because anytime I bring up YAGNI, programmers often get very angry at me. So the YAGNI principle stands for you aren't gonna need it, And I'm going to change it to a little bit here. I usually put the word yet. And it makes such a big difference when you say yet, because it pleases the programmers. You mean I can do it later? It's like, yes, sweetie, sit down. You can do it later. So the point really is, you aren't going to need it. How many times have we written code that we really don't need? Yeah, that's called courage. Those people who raised the hand admitted it. Others are in denial. Absolutely, right? We all have done that. Absolutely. Now, our typical day at work, what do? You're sitting and writing code, and your tester or business analyst comes and says, do you understand how this works? And what do you say? I don't understand how it works, but don't bother me, I'm busy writing code, right? So we always like to write code. Whether we understand what we're doing or not doesn't really matter. So we end up creating monstrous amount of code. Now, I'll give you an example of this. I was working with a client where they had implemented a particular solution to a problem, and it had resulted in such a huge amount of errors and problems, and they have invested a great amount of team to fix it. About 2-3 years into it, they called me and said, well, this monster has gone out of control. We have tamed it. It's quiet, breathing in that other room, but you have sedated that monster called the code, and you can come and help us to fix it. Well, I went and looked at what they have done, looked at their code, and eventually I asked them what problem they're trying to solve. And they've been trying for about 4 or 5 hours to explain what the problem is. And eventually we found out they have written code for a problem that doesn't even exist. And you can imagine what happens when we write code for problems we don't have. That's a burden we have to carry with us, and that's a code we have to develop and maintain. Now, I will tell you what's the real difference between a novice programmer and an experienced programmer. The one who is just coming out of school, you go to them and say, hey, we got a project, and they're like, can we write code, right? Experienced programmer will try to avoid writing code, right? You go to a programmer with experience, we got a project. Can we just buy something now, right? Because people know that the code you don't write, hands down, has the least amount of bugs in it, right? So experience gives us the power to not write software so that we can focus our time and effort writing software that's really important to write. So YAGNI principle is where, when you look at a particular problem, ask yourselves, is this part of the design something I definitely need right now, or can I postpone it? Now let's take a look at an example. Let's say you wrote a code 2 days ago, and that code is sitting there, and you spent enough time writing it. And I come to you and say, hey, you don't need that code. What are you going to say? Yes, he denies it, absolutely, right? He's going to take up against me. He's going to fight with me because he's like, I wrote that code. I stayed up late writing it. Damn, you better use it, right? That's what he's going to say. He's going to be angry at me if I even suggest you don't need it. But let's say you are going to write this code 2 weeks from now. And I'm coming to you and saying, hey, you know what? This class we plan to write 2 weeks from now, guess what? We don't need to write it. What are you going to say? He's very happy, right? Absolutely. That's our mission, to make him happy, absolutely. We want to make sure that we're happy not writing that code we don't have to write. Well, this in development, in agile development, we have a special name for it. We call it the last responsible moment. Now, there is a difference between procrastination and last responsible moment. Procrastination is where you have to do something 2 weeks ago, and you didn't do it still. That's procrastination. Last responsible moment is you do it at the time when you no longer can wait. I'll give you an example of this. I live in the US, and Scott will assert this to you. We all have to file tax return every single year. Paying tax is painful, but filing tax is more painful. So one thing I do is the tax return is due on the 15th of April. I always file my tax at 11 p.m. on 15th of April. At 11 p.m., I walk into the room and I have a conversation with God. If I'm going to live, let me know now. I got to file this stupid tax return. I cannot wait any longer. So why would you want to file a tax return if you're going to die anyways, right? So I'm going to wait until the last minute and file the tax return. So that to me is last responsible moment. I tend to do that for writing code as well. Yes, I love writing code, but I would rather write code that I'm happy to write, useful, provides value with automated test on it, which means I've got to prioritize what I'm going to write. And to prioritize what I'm going to write, I got to focus on the direct value proposition and only write code that actually makes sense and postpone things until you no longer can postpone. But as a result, what we end up doing is we realize a couple of different things. That the code we postpone to write, eventually we write it, or most often than not, the code we postpone to write is something we actually don't need, and we avoid writing that code. And third thing, the code we postpone to write actually ends up looking a lot different than what we originally thought about. And the reason simply is, how many of you believe that you're going to be smarter tomorrow than you are today? Okay, most people do. Others are still processing that question. That's okay, that's all right, right? So absolutely, that's the main idea. So we definitely will be smarter tomorrow. Actually, let me ask that again. How many of you think you're going to be smarter tomorrow than you are today? Okay, that's a little bit better. We'll keep working on it. By the end of the conference, I hope everybody raises their hand, right? So absolutely. That is called hope, right? We're going to be better tomorrow than we are today. Absolutely. So that's great. That's a YAGNI principle. Now I want to talk about one more principle. There are different names for this principle. Sometimes we hear the word cohesion, but this really is the single responsibility principle. So the idea behind the single responsibility principle, is that it really says every module of code, a class, a method, a function, whatever it is, it should focus on doing one thing and one thing very well. So if I show you a piece of code and ask you what this code does, and you say this code does this and, right there is a giveaway, the word and. So we want to make sure that the code does one thing and one thing extremely well. That is basically single responsibility principle. Now, when we write code, we have seen this fail a lot in so many different places. Now, let's take a look at an example of where this could be a problem. Now, there are several places where we can actually see this, but let's look at one thing that I'm sure everybody has seen along the way. So, long methods. So, what do I mean by long methods? Methods that are 5,000 lines long, 10,000 lines long, 15,000 lines long. We could actually do an auction. Who has seen the longest line of code here? 15,000. Do you have seen more than that? What was it? How many? 30. I heard 30. Anybody else? 6? Really? I won't even ask anymore. Who here has seen long methods? Almost everybody raises the hand. Who here thinks writing long methods is a good idea? Raise your hand if you think. Not a single hand goes up. That's called cognitive dissonance. Why do we think it's a bad idea, yet we see long methods? I'll tell you why. Because the guys writing long methods are right now sitting at work making those methods longer as we speak, right? So that's why methods are long. Sorry. So nobody here thinks long methods are a good idea, but let's talk about why long methods are a bad idea. So fire away. Why is it a bad idea? Tell me a few reasons. Unreadable. Hard to maintain. All right. What was that? Complexity. Absolutely. Hard to test. What a wonderful thought. Hard to test it. The permutation and combination, you got to go through it. Oh my goodness, right? How do you really write test on it? What else? So, so fails SRP, right? It's actually multiple responsibility. Multiple, right? Absolutely. What else did I hear here? Hard to debug. Okay. Oh, wonderful. Coupling. Very, very nice. Lot of coupling. Anything else? Not reusable. Wonderful. Did you realize something here? The code that is long leads to duplication of code. We talked about this earlier. You said it's because people are lazy and people are fearful. There's a third reason. Here is a very long method. And what you want is this 4 lines right in the middle. You're like, oh, well. And where you need this is inside of this very long another method. So what do? Pop. right? So, absolutely, right? So it leads to long methods as well. So nobody here thinks it's a good idea, but we see people writing long methods all the time, right? So why do people still think it's a good idea to write long methods? Well, some people come to me and say, well, it's a good idea because it improves performance. I tell them, you know what, you are right, but the last time that happened was Nixon was the president. Long thing has changed since then, right? We're dealing with better compilers, better computers, better architecture. That doesn't hold anymore. So the question is, we all know writing long methods is a bad idea. How do we fix it? I've got one last suggestion for you to fix it. So go back to work on whatever, tomorrow. Sit down, or Monday, go to work Monday, sit down. Don't speak a word, just work. You know the colleague of yours who writes long methods? Let's call that person Joe. Joe comes over and says, hey, how was your weekend? Well, you could say, oh, the weekend was great. I went to the movies on Saturday and went to the park on Sunday. But don't say that. Instead say, oh, the weekend. Well, exactly at 10 a.m., I sat in my car, put on my seatbelt, reversed the car, turned left, went about 200 meters, stopped at the stop sign, took a right turn, went on about 2 blocks, and then took a left turn. Keep going like this for however long you can go. At some point, your colleague will say, have you gone mad? You say, no, I thought I'll tell you how my weekend was, like the way you write code. Okay? So the point really is, we don't speak to people that way. How do you speak to people? Well, I went to the movies on Saturday and park on Sunday. Well, I may be excited and say, really, which park did you go to? Notice I'm not talking about the movie anymore. Oh, I went to the park over here by this particular airport. Oh, really? Is that a family-friendly park? Now we are in a much more lower level of detail about the park exactly. So the point is, we talk in these bite size of abstraction. And when we write code, what are we doing? Guess what? We are communicating. That's what we do when we write code. So why would we want to do it any other way? So the point really is, we want to definitely avoid long methods as much as possible. But then the next question is, how long is too long? Well, sometimes people say 100. And I'm sure somebody else in the room says, 100? That's very long. I'm a Java programmer, and more than 20 lines is wrong. And the minute you say this, the Ruby programmers in the room is like, 20 lines long? No, we write everything in 7 lines long. Immediately, like Clojure guys in the room say, 7 lines long? We write everything in 3 lines. There is no way to win this battle. Well, here's one suggestion. What if we can guarantee that every function fits into one window? So every function that we write, the entire function fits into one window. No, don't try to lower that font size. So the point really is, we could argue about the length of the functions. There's no real good way to answer this. But let's think about this a little differently. Let's think about this as how we should think along the lines of long functions. Long is not the number of lines, so let's readdress this. So let's say we have a list of integers over here. We'll call it numbers for a minute. And what I want to do here is say arrays.asList, and let's say a bunch of values that I have here. Now let's say the problem I have on my hand is to say that I want to take each of the numbers, let's say, and I want to say numbers.stream, and I want to take each of the numbers and do a mapping of this number. And what do I want to do with the mapping? Well, I want to say in this case, given an element, double each of the element. And then for each of the element that we have in here, I want to simply print out the value that we have on our hand. So let's go ahead and say print line over here. So if I do this code, that's not very long at all. That's great. We just doubled each of the values and we printed it. Great. But let's say the problem slightly changes on us. And the change is, you want to double even numbers and you want to triple odd numbers. Now, what is our first instinction? We'll say, oh, you know what, we could do that. And what we could do now is we could put a little curly bracket over here. And then we could say, in this case, if e is mod 2 is equal to 0, then we could say return e times 2. And then, of course, else what we could do in this case is we could return over here e times 3, for example. And that could be the result of this particular operation we perform. And we could say that's our code for doubling certain values and tripling certain values. Now, if you show this code to somebody and say, is this long? And now we are in an argument, whether this is really long or not. But that's not the way to think about it. If you really think about this code, just focus on this. What is this code really doing? It starts with a collection of values to begin with. It performs certain operation on each of the values, and then it says, take all the values in the list and print it out. But if you notice over here, notice right here, this code, what is that doing? So if this is where I am in the main, the highlighted code is like that, right? I'm one level down in the level of abstraction. So this is like climbing down a stair, and you went from a higher level of abstraction to a lower level of abstraction. Well, now it's very easy to figure out what's going on, and the way you fix it is by doing what's called a slap. I'm sorry, I don't mean do this physically on your fellow developer. That's not slap what it means, though some of them deserve this. But the point really is, this stands for single level of abstraction principle. So the idea really is, you want to focus on a single level of abstraction. So what does that really mean? Well, given a particular function, you want to make sure single level of abstraction principle. So the idea is, when you're writing code, don't worry so much about long versus short. Instead, think about single level of abstraction principle. Are all the code in a certain level dealing with the same level of abstraction? Am I working with the collection, or am I suddenly middling with a little value within a certain element? Am I working at a logic level, or am I all over the map, working on logic, fiddling with the database over here, trying to set the locking of the database transaction, then updating the UI? That is an example of a lack of level of abstraction. We are all over the map. So single level of abstraction is something very important to think about. But these things really that we talked about so far are about a method. But this also applies to a component level. Let me give you an example of single responsibility principle without really going into code, so it's easy for us to see what this means. When I was a kid, I really sympathized my parents because they had to bring me up in life, and they had a really tough time. They were trying to teach me good lessons. They said, Venkat, you got to do this. Venkat, you got to do that. But I never realized any of those. And I would come back from school, and it was so much fun to jump out and play on the streets. So I would come back from school, open the drawer, and throw my stuffs in there, barely shutting the door and running away. This was easy, because I had to only throw things in and run away. However, when I wanted things out of it, oh boy, it took a lot more time. You can relate this to code, right? Writing code is easy, maintaining is hard. Very similar to that. But anyway, and I would come back and I would say, oh, I need a sock. What kind of sock do you want? I want a blue color sock. Well, guess what? The minute I find a blue color sock, then the search starts. Because I got to hunt through where the other blue color sock is, and I would get every other color. Some were, some not, but that's a different question. But the point really is, it was really hard to figure these out. And I would have books in there, clothes in there, other stuff that's been in there, and nothing was really kept organized. And my parents tried to tell me, this is not the way to live your life. You got to keep things separate. You got to keep your books in one place, your clothes in another place, but I never, ever was able to do it. Now, you may look at me and say, okay, Venkat, that's interesting. That's how your childhood was. What happened? How did you fix it? Well, I got married, okay? That took care of it really well, right? So the point really is that you got things in the right place, right? In fact, the other day I was working away in one of the foreign lands I was in, and I really wanted to code something in one of the books I was writing, and all that I had to do was call my wife and say, sweetie, I really need help. Go to my bookshelf, third book on the shelf. I wanted to pick that up and look this in the index and read it for me. That kind of discipline only a woman can bring to you in your life, right? So the point really is that now I'm a lot more organized. Not that you want to come and look at my room, but the point is, that's exactly how we do in code. You want to keep things separate. You want to keep your GUI level code separate from the database code, from the logic code, from other things that you do in terms of rules. And what's the reason for it? And the reason for it is when a code is really focused and does things really well, then the reason for a code to change is a lot less than when everything happens in one place. The other reason why this is a good thing is when somebody comes down to make a change to a piece of code, they don't have to wade through the complexity of things that are not relevant to what they are doing. So it really minimizes the amount of time people have to spend time fixing the code. So that is basically what cohesion is, and that is something we have to definitely strive to really improve. Well, the next thing I want to talk about is open-closed principle. But before that, any questions, comments, just about any curiosity? I would like to hear something from you. Anything on your mind? Yeah, please. What? I'm using an editor called TextMate. Yes, that's another great idea to talk about principles. Things that do less actually do more. This editor has no clue what I'm doing, so I can do anything I want with it. Whereas if an editor knows exactly what I can do with it, that's the only thing I can do. That's, again, a very good design principle. I really appreciate this in languages, right? This is what is the primitivity of API, primitivity of the tools. So this tool doesn't have a clue. It simply allows me to type stuff, and it says, if you want to do something, it's yours, do it, right? And as a result, I can push it to the shell script, run things, and display the result. So it actually reflects back on good design principles. So thanks for asking that question. Any other questions or comments? All right, so let's continue further. We're going to talk about open-closed principle. That's the next principle. This was coined by Bertrand Meyer. So what is open-closed principle? Now, the open-closed principle says a module of software must be open for extension, but closed from modification. In other words, you want this code to do something more than what it did before, but without changing it. Now, that may appear to be a magic at the minute, but how do we really make that work? I won't be able to give you a full example of this here, but I'll give you about half an example, and then I will point you to where you can get more information about it. So let's think about a problem here for a second and see how we can solve this particular problem. Let's say we have a class that I want to start with, and a class called car for a minute. And the class car is going to have a year over here. So I'll say int, so we'll say private int year. And then I'm going to say over here a private engine, and we will call this as engine, and this is going to be also engine. So now that I have these two, where is the engine? Let's go ahead and say class engine. And the engine is going to have, I got to warm up my fingers still. So the class engine is going to have really a power property. That's all we're going to have in here. So let's go ahead and say engine, and this is going to be a private int power, and this is going to be a constructor that is taking the engine. So let's say power is what I'm going to pass to this, and this is going to be power equals PWR. So we have set the value in here. Great. Now let's say I want to create a car object, so we can say public car, and let's say int the year over here, and let's say engine the engine. So I've got a constructor going for this, and I'm going to say year equals the year, and I'm also going to say the engine is equal to the engine as well. So now I have a little car ready for me. Now what if I were to say something like car 1 equals new car 2014 comma new engine, let's say 10 over here. So we created a little car object. Let's go ahead and print out what's in this car. So car 1. And of course, to make this work, I'm going to say public string, a toString. And all I'm going to do is return string.format over here. And in this case, I'm going to simply print the year. And I'm also going to go ahead and print out the engine itself. So we'll say year comma engine. Of course, for this to work meaningfully, let's go to the engine for a second and say over here, public string toString. And in this toString method, of course, I'm going to simply say return. Let's say string.format one more time. This is going to be a %s, a %d. And let's go ahead and say get class over here and the power that we have on our hand. So this is going to print the engine information along with the car. Great. But let's say we want to make a copy of this car. So for now, pretend that this is C++, right? I know this is not C++, but pretend it is. I mean, that should be easy to pretend, right? Because C++ programmers do this all the time. They pretend they're working something else when they code C++. I know your pain. I used to be one of those guys, did that for several years. So pretend this is C++. Now, let's go back here and say car 2 equals new car 1. and I want to print out car 2, right? So if I try to run this, what will happen in C++? Will it work in C++? I'll give you a clue. The answer is either yes or no. It will. Well, it'll work in some definition of the word work. What will C++ do? It'll make a, there you go, shallow copy. Now, this is a semantic issue in C++, right? It's a shallow copy. And you don't want shallow copy. When do you don't want shallow copy? Most of the time, right? So what does the language do? It falls on messing things up. That's the default, right? So what do you do normally? Either you write a copy constructor or you disable a copy constructor, right? Well, Java said, well, no, we're going to fix it. How are you fixing it? No copy constructor for you, right? Well, that kind of is like running away from the real problem. But in the case of Java, it doesn't work. Why not? Because Java has no copy constructor by default. Well, that doesn't stop us from writing one. So I'm going to say public car other. And what should I do here? Ear equals other.ear, and engine equals other.engine. So there you go. What do you think? No, that's called collision, not copy, right? So these two cars end up having the same engine. Definitely you don't want to do that. In fact, how do we know that that's a problem? Well, we can try this here. We can go back and print the hash code here in the engine. So we could say, for example, hash code. And then we can see that the hash code being printed, you can see that both of them are exactly the same. And you certainly don't want the same hash code. And so what do we do? Again, not getting into the details of hash code right now, how do we fix it? Well, we could say, for example, engine equals new engine, and then we could say other.engine. And of course, for this to work, the engine now needs a copy constructor. Don't you see the love spreading around here? So engine, other, and what should you do in here? You're going to say power is equal to other.power. And so now that we have made those changes, we can see that the hash code is different. We made a copy of this object, so lovely, isn't it? Well, looks like it's working, except, let's say a few weeks goes by, and we're going to come back to this and say class turbo engine, which is going to extend from engine, right? So it extends from engine. Well, if this was C++, you would have said colon over here. So colon public, right? That's what you would say in C++ to extend from this engine. So I have an extends engine right here on my hand. And now what do? Well, I'm going to say over here public turbo engine, and I'm going to say int power. And then what do you do in this case? You say super, and then you say power. Why do you say super? Because it really is not. It's boring. Okay, so you had to say it. And then you say public turbo engine, and then you say other, and then you say super, and you say other. Well, in the case of C++, you would have said colon, and then the base class name and passed it around. So you could have written the turbo engine constructor, right? So here's my question to you. Now that I wrote the turbo engine separately, is it legal to change this to turbo engine right here? Will the compiler accept it? Absolutely. Will the code work properly? No. So when you run this code, what's going to happen? Well, when you run this code, you can see I slipped. That's exactly what happened. Well, you see, you feel cheated, don't you? This other car you made a copy ends up with the engine, not a turbo engine. Hey, what happened? Well, the reason is, this is kind of sad, but the reason is the word new as we know it. And it turns out that new is not polymorphic. Well, I got to be a little careful when I say it. New is not polymorphic in C++, Java, C#. It's not fair to say new is not polymorphic. There are other languages, like Ruby, one of my favorite languages, where new is polymorphic, but not in the mainstream languages that most people in this room probably are using. I use mostly Java and JVM languages myself. So in most of the mainstream languages, I use new is not polymorphic. But we got to fix it. But I got a good news for you. Don't worry, this is easy to fix. I'm going to simply say if engine is instance of is there anything funny? Okay. So if it is instance of a turbo engine, I'm going to say engine equals turbo engine. Okay, turbo engine. And then what do I do here? This is going to be new engine. and then it's going to be another turbo engine, and other dot engine. So that's nice, isn't it? And then, of course, else. So else, I'm going to just keep whatever it is that is right now. And I probably made a mistake or so, but we'll find out and fix it. So if the engine is actually other dot engine is, right, not the current engine, other dot engine is turbo engine, and we can then make the cast. And class cast exception, what did I do? So this should be new turbo engine. That's what I want to create over here for the other object. So this is going to be new turbo engine. So pardon me, there we go. That's a new turbo engine. So we could write that way. Now, if you send an engine, it works. If you send a turbo engine, it works. What do you think of this idea? Yay or no? You guys have to think positively. This is job security, right? Every time your system evolves, you can go put a little bit more code in there, right? So this is job security. But eventually, you don't want to have the job, right? It becomes really boring. Now, this is basically attacking what's called the open-closed principle. What does open-closed principle say? Open-closed principle says that a software module must be able to evolve without having to modify the code. So a way to fix this would have been, rather than using this, what we could say is we could say, other engine, rather than this mess that we are dealing with here, we would simply say engine equals other dot engine dot clone, for example. Now, this would, of course, make a copy of the engine. So we could say engine like this, and we could make a copy of this. So, but why? What's the big difference? What's the difference between new and clone? Well, the difference is, while new is not polymorphic in languages we are talking about here, clone can be polymorphic. Now, remember what polymorphism is. Polymorphism says, go ahead and call a method on an object, but the instance of the method or the implementation of the method that's called is based on the type of the object and not type of the reference. Even though the type of the reference is engine, it'll call the clone in the appropriate implementation at runtime. So in other words, we are saying, I don't want to bind statically to this method. I want to postpone until runtime. Now, unfortunately, though, I mentioned to you that I'm going to only give you half the solution because it'll turn out this actually doesn't work eventually. And I was reading a book called actually it's called Effective Java. I was mentioning to Scott earlier that I grew up reading his book on Effective C++. I admire books like that really helped me become a better developer. And so Effective Java is one thing I've read. And Effective Java says, do not use clone, but use a copy constructor. Now, I just finished telling you don't use copy constructor, use clone, and they tell you the right opposite. Well, it turns out a right solution is neither to use copy constructor, nor to use clone, but to use a combination of the two together. And if you're interested in looking at this more, you can go to my website, agiledeveloper.com, and I have an article in there written several years ago that goes deeper into it, but I won't go into more of this depth. But the idea really is this. If you look at C++ for a minute, can somebody tell me what's instance of in C++? Dynamic cast. Can somebody tell me when dynamic cast was introduced in C++? 1003? C++ has not been that long. Oh, you said 2003. Okay. Is that reasonable to say, Scott? 2003? No, a little earlier than 98? That seems more like it. So the point I wanted to make is this. C++ had dynamic cast much after Java had come out. For a long time, they withheld dynamic cast because it'll be a result in poor quality code, violation of open source principle, so it's frowned upon to use dynamic cast. But however, we have seen code where people take an object and go through a sequence of if-else statements or switch statements where they compare to objects. Have you ever seen code like that before? Yeah, we see that, right? And that's poor quality, but it's okay to compare to a type like your own type because you're not going to change your code. So the yardstick to use is this. You should always make sure that your code is not going to keep changing once you introduce a new type or new object in your system. So in other words, as you extend your system, your rest of your code should not have to change. Why is that? And the reason is really economics, right? It is easy to add a little bit of new code than change existing code. Because changing existing code takes effort to understand that code. We also have to make sure we don't break anything while we are changing existing code. Whereas to really add a little bit of new code is a lot easier, relatively speaking. And so extensibility can be attained by doing just that. And that is really the point about the open-closed principle. Any questions or comments about open-closed principle before we move on? Yeah, please.
Is there any advice you can give how to keep with YAGNI principle?
The question is, how do you keep up with the YAGNI principle? The first thing my advice is, avoid emotions. Now, seriously, right? I mean, I'm the last guy to tell you about this because usually my children are like, Daddy, are you angry? No, I'm just coding. So the point really is, right? But keep your emotions out, right? And so if somebody says, do we really need it? Rather than trying to challenge that, let's entertain the thought, well, why do we not need it, right? And what if we postpone it? Hey, can I come back and do this? So think of the code you're going to write as a cheesecake. It's for you. You can write it a little later on. So handle the emotions first of all, please.
My question is specifically in context of OCP.
In the context of open-closed principle, yes. No, that's a brilliant question, absolutely. Because open-closed principle says that you better not make it bound, coupled to the object directly. You need to have a level of indirection, right? But on the other hand, that's a brilliant question. And on the other hand, the YAGNI principle says, don't do what you don't have to do. So that's a wonderful thought to have. My recommendation for that is, well, let's think about this for a second. If you look at the time that I started coding decades ago, we didn't have modern IDEs at that time. Really, we didn't have. My editor was VI. And I used to spend 12 hours a day coding using VI. It was a lot of hard time back then, if you don't realize, right? Today, kids are like, oh, I got this IDE, fancy IDE, right? Back then, a small change like changing a class name can be very expensive. Now, today, you can gently right-click on the IDE, and before you can blink your eyes, it refactors your entire code. So the point I'm making is, when it comes to making sure that we don't make change, we don't make change in the future, I want to think about it as make change affordable. And what that means is, if a change is really cheap, I don't want to protect myself from that change today. If the change is expensive, I want to protect from that change because obviously it's going to cost more to make the change. So in other words, when all these thoughts come to my mind, some of them may be a little conflicting with each other, and I would ask myself, yes, I don't want to fail OCP now, but I don't clearly understand yet what other classes I'm going to have. So this is a good example to really look at it. Remember how I wrote new engine to begin with? That's the time I think we should still do new engine and stay with it, because that is YAGNI at this moment. 3 months from now, we got a turbo engine come in. Now, I shouldn't put the if-else. Now is the time to introduce an interface and make it extensible, because it's no longer YAGNI, it is now, and we feel it, right? So don't abstract this on day one, but wait for the first change to come through. When a first change comes through, then implement the change and say, well, what is the likelihood of similar change coming up in the future? It already came through once, so probably it's likely that it'll come through again. But don't do it in isolation, but consult with your business people and say, hey, are we going to see some things like this? What's the probability of something happening like this? And if the probability is reasonable, given the fact it already happened once, it's a good time to apply the open-close principle, but not any sooner. Did I answer your question? Absolutely. Excellent. Really good question. Thanks for asking that. So that's really a way to think about it, but I still think we should control our emotions. So that is basically an idea about how to really approach open-close principle. Any other questions, comments before we move on? All right, let's talk about one more thing. This is called Liskov substitution principle. Now, Liskov substitution principle says that a user of an object should not know the difference between using a base object versus a derived object. In other words, really beautifully said, what this principle says is that when we use inheritance, we have to think about substitutability. I'm going to type this word, substitutability, right? So we got to think about the word, I failed. Okay, about substitutability, right? So we have to think about substitutability. In other words, the question is, I've got a class A, I want to write a class B. Should I inherit B from A? Now, there are two things we normally want to use, right? We want to reuse a code, so reuse a code. Now, unfortunately, inheritance is not reuse. Inheritance often is abuse. So inheritance is one of the most abused concepts in programming. Why? Because if I want to reuse a piece of code, reusing it is a lot easier. But if I say I want to inherit, I take on a burden which I may not really be willing to take, but I accidentally take it. And what is that? In other words, if B inherits from A, anywhere an object of A can be used, an object of B can also be used. Whether you like it or not, you bought into it. And that usually is a burden for us to carry through. So let's think about this for a minute. Should I use inheritance or should I not use inheritance? So LSP, or Liskov substitution principle, I should actually type this here. So Liskov substitution principle says, so this is going to be substitution principle, right? So what does the substitution principle really say? So the substitution principle says that use inheritance only when, hey, I got it right this time. Okay, use inheritance only when you really mean substitutability. And what that really takes forward is the following. So a derived class must require, so it says must require no more than the corresponding services of the base class and should promise no less than the corresponding services. In other words, it says when you use inheritance, your methods that you override in the derived class cannot require any more and should not promise any less. Now, let's think about this for a second. Now, way back in time, in Java, we had a class called vector. It is still there, but not many people use it. Now, there is also a class called stack. Now, you all know what a vector is. A vector is where you can take a collection, you can insert something in the middle, you can remove something from the middle. That's what a vector is. You know what a stack is? Stack is a LIFO. Last in, first out, right? Absolutely. Now, what they did is they said class stack extends from vector. This is exactly how it's implemented in the JDK in Java. Now, what do you think? Is this a good idea or a bad idea? A bad idea. Why? Well, why did they do this? Hey, it's reuse. We don't have to do any work for the stack. We can simply reuse the vector. But here's the problem. Let's imagine for a minute that Dominic has a function, and his function is going to take a vector as an object, right? He says, I take a vector. And what does he do? He receives a vector. So Dominic sends a vector to him. What does he do? He takes his vector and sends it down. And the other gentleman, what's your name, sir? Piotr? And what does he do? He takes this vector and he's going to insert elements and remove elements from it, right? Everything is fine. I come along, create a stack, and hey, stack, yeah, here you go. And Dominic receives it. What does he do? He sends it down, and what does he do? He says, nice vector. And then I get back my stack, and the stack kind of looks a little tired. I said, stack, how did your day go? And the stack is limping. I feel violated, right? This poor stack has been abused all over, right? What did you do to the stack? He's like, what stack, right? Because all I did was I passed the vector around, right? And that is the reason why this is a terrible idea. In other words, the stack is not substitutable. A poor, innocent class wanted to reuse a vector, not stand in for a vector. That's a tall order, right? To stand in for a vector rather than simply using a vector. So we got to be very careful with LSP. Let's think about this for a second in terms of different languages also. So let's talk about C++ for a minute. Can you say, you have a base class, and in the base class you have a private F1, a protected F2, and a public F3. So you got 3 methods, right, in C++. A public method, a protected method, a private method, right? Of course, using the C++ language syntax, you would have written this. Now I write a derived class which extends from base. Oh, it's worth spending just a minute on this. Have you ever wondered why in C++ we use this word called public? I really hate this word public here. But the intention was, when you make an inheritance, by putting public, you are saying, I want substitutability. Meaning, an object of derived could be sent to an object, a function that is accepting a base. That's what that word public means. If you say private, also known as bad idea, what that really means is my goal for inheritance was a pure object reuse. I never want to be substituted for the other object. So you can say private inheritance, you can reuse the base in a really bad way, but nobody can come to you and treat this object as the other object. So in C++, if they had said stack colon private vector, we wouldn't have the problem we talked about. Even though that's still a bad inheritance, it's not as bad as the other one was. But how many people here actually use private inheritance in C++? Wow, that many? Okay, all right. But rest of us know not to do it, right? So that's the whole point. So absolutely, and that's example of where that's being used. Anyway, back to the scheduled program. If you notice over here, we have a derived class which extends from the base class. Question for you. Can I take F1 and make it public in the derived class in C++? Yes. Yes, you can. What about F2? Can I take F2 and make it public in the derived class? Yes. Can I take F2 and make it private in the derived class? Absolutely, yes, you can. What about F3? Can you take that and make it public, private, or protected in the derived class? And absolutely yes. Because in C++, you can do whatever you want to do, right? Nobody ever stops you from doing it. But of course, how many of you can answer what happens? Very few people can do. This is why I love C++ programmers. You know why? Because every day they go to work and say, I wonder what it's going to do today, right? Because we have no clue, right? Please. How we can override it? Yeah, how do you make sure people don't do something like that? That's the question, right? Is that the question? How do you protect from such poor overriding? Huh? Oh. Yes. Got it, got it. When you use the override keyword, what language are you talking about? C++. Okay, so you can do, but is that a required keyword? Is that a required keyword? Or required to use the word override? No, no. So that's kind of where the complexity actually brews in, right? If a method is not virtual, you're not supposed to really have it in the derived class, and so on, right? It ends up hiding. Same problems creep in here as well. So we need to put a little bit more effort. We need to use good compilers, good tools to check for those. What about Java? If a method is public, can you make it private in the derived? No, the language would not allow you to do. What about C? Anybody who programs in C# here? It's okay, you're among friends. I do too. I program in C#. That's okay. It's okay, right? Absolutely. We'll be proud. Absolutely, I do too. So what about in C#? Is there a requirement restriction? It's got to be the same, right? If it's public, public, private, private, protected, protected. Well, the reason why the word extends is being used is that you're extending it rather than restricting it, right? That's the reason why they chose the word extends in Java, that inheritance should actually extend. All right, so with all that said, The last principle I want to talk about is called the dependency inversion principle. But I'm not going to talk about code here. I'm going to talk about something else to understand what DIP is all about. So I'll tell you where I learned about dependency inversion principle. I learned it in Norway during my very first trip to Norway. So this happened a decade or so ago, maybe 15 years ago. This was my first trip to Norway, and I was like fascinated. This is a foreign land I've never been in. I want to learn about it. I went in there. Well, I'm a very, very addictive coffee drinker. He asked me, what do you want to come and speak here? I said, as long as you have coffee, I'm ready to come, right? So I'm a coffee drinker. So I go to the hotel, and to my surprise, there was no coffee machine in the hotel. And I got really eager. I said, how could you not have a coffee machine in the hotel? I went to the reception and I kind of fought with them, and they finally said, you know what, we don't give coffee machines. This is my personal coffee machine. You can have it. And I'm like, thanks, and I have my coffee machine now, right? Anyway, I wake up pretty early in the mornings, and I also go to bed fairly, on time as well. And I was about to go to bed, and this poor Venkat wanted to go to bed. And I looked around. I was a bit shocked because there was no clock in the room. And I'm quickly thinking, maybe it starts with a C, like a coffee maker. Maybe something to do with C. They don't provide anything that starts with C. So there was no clock. So I went to the reception and said, excuse me, and the lady's like, what is it now that you want? Well, I don't see a clock in the room. She said, yes, of course, we don't give clocks in the room. Well, how do I deal with this now? And I was in a panic. And she said, calm down. Why do you need a clock? I said, I need a clock because how could I possibly wake up in the morning without a clock? You see, I have a clock by my bedside. It makes such a horrible noise in the morning, I cannot sleep for the rest of the day. I want a clock like that. And the lady was a little surprised. She thought about this for a minute and said, let me understand this. I don't understand why you need a clock. I said, I just explained to you why you need a clock. And then she said, well, what you really meant is you need an alarm. I said, lady, don't get technical on me now, right? And it occurred to me, she is right. I didn't need a clock. I need an alarm. And I was bitter. I said, okay, so you're saying I need an alarm and not a clock? Uh-huh. Okay. I don't see an alarm in the room. Well, there's one. Really? Where is it? She said, did you turn on the TV? No, I don't watch TV. Well, this week you will. It's like, okay. And I go back to the room. I turn on the TV. It says, dear Venkat Subramaniam, welcome to this hotel. I'm like, hey, this is awesome. And there's a feature there you can set the time on. I'm a believer in TDD. So I set the alarm for 2 minutes from now. Turn it off. Wait for 2 minutes. It starts up. Hey, this is awesome. But I want to make sure it's working consistently. 2 more minutes after that, right? It worked. So I set the alarm for early in the morning, and I went to bed. Well, now I'm in a dark room, and suddenly I hear a voice. I wake up, and it's dark. And honestly, I don't know where I am. And I look around, and the voice is increasing by the second. It's like, oh my goodness, somebody's voice is getting louder and louder. I jump out of the bed, and now I'm like trying to, you got to understand the problem in concurrency here, right? I don't know where I am. There's a voice in the room, and it's increasing. I'm trying to process, where am I? Why is there a voice in the room? And what's going on? And eventually I realize the TV is on, and I'm trying to find the remote now to lower the volume because I don't want this to be really loud and wake up the neighbors. And can you imagine? I calm down with my heart pounding, and I look in front of me. There's a guy in suspenders. Hello, this is Larry King Live. Can you imagine waking up to Larry King Live in the morning? I had to go to therapy after that, right? So anyway, now that I was awake and scared, I started thinking, this is awesome. She is absolutely right. Here is Venkat depending on clock, both of which are concrete. Instead, there is Venkat, she said, and Venkat, poor Venkat, should never depend on clock. He should depend on alarm, she said. Now, what does that mean? Well, my clock, remember the favorite clock I have at home, is inheriting from the alarm. So you could say that there is a level of inheritance sitting here. I'm going to use my artistic skills here, as you can see, right? So that's going to be an inheritance on the alarm. So you can see that's going to be inheriting from the alarm, right? Okay, that's the best I can do here. A carrot. There we go. So that's an inheritance. But here's the beauty, right? Not only do I have this clock, Then she said, your TV is an alarm too. What a great idea. Now I was watching TV that week. But I couldn't go through it. Quickly, this was the days before cell phone, right? And so I immediately wrote a little program on my computer. And I had to leave my computer on overnight, but promptly at the time, my computer will make about the same ugly noise as my clock would. And so I was able to use my computer as my alarm at that time, so I could use a computer. And when I was growing up, I had the world's best grandma. And my grandma, I would go to my grandma and say, Grandma, I got an exam tomorrow. Could you please wake me up at 4 o'clock? And promptly at 2 o'clock, she'll wake me and say, don't worry, grandson, I'm still awake. I'll wake you up at 4, right? So the point is, we can have different implementations of an object. So dependency inversion principle says a concrete object should not depend on a concrete object. Instead, both the concrete object should in turn depend on an abstraction. Notice the concrete Venkat here, person, is depending on a concrete clock. Instead, we said, here is an alarm. Let the concrete object Venkat depend on alarm. Let the concrete clock depend on alarm. Now we can alternate the different implementations. If you ask me, this is one of the principles I've used the most because I use this every time I do mocking, for example. So in the case of test-driven development, this has been extremely useful. This has been very useful also in simply following open-closed principle. So a lot of times, I found this to be very, very powerful. But having said that, I want to emphasize one other detail, and that is, while all these principles are really awesome, we got to be very careful using them. Because using them incorrectly can result in poor quality software as well, and therein lies the challenge to know when is the right time to use some of these principles and when not to use the particular principle. And I find that a better way to use this is through collaborative effort. So as I develop software, I would often sit around with my team of programmers. As we are pair programming, we would ask each other, hey, what about this code? Can we do this? And our vocabulary is, oh, if you do this, the code would violate OCP. Oh, look at that code. If you do it that way, you will fail the drive principle. But learning and using these vocabulary gives us a communication tool. And as we collaborate and work together and pair up, we can make really good use of some of these principles. I sincerely hope that you found this useful. Thank you very much.
I think I have only 2 words to say after that. Venkat Subramaniam.